students. Welcome to our YouTube channel Experience Tutor. Today we'll discuss Class 9 Science Chapter 11 Work and Energy Part 2. And here is our welcome message. Before we begin, we have a humble request for you. Please subscribe our channel, like and share it among your friends and relatives. And please click on the subscribe button to support us, and also click on the bell icon to get automatic notification whenever a new video is uploaded. Now let us begin our today's lesson. In the last class we have studied about all about work. So in today's class we'll study about energy. Today we'll start with energy. So, few things to remember. Sun is the biggest source of energy. Most of the energy sources are derived from the sun. Some energy is received from nucleus of the atom, interior of the earth, and the tides. So, sun is one of the source. Nucleus of the atom is one of the source of energy. Interior of the earth, we know that interior of the earth uh, is very hot. Molten metals, it is so hot that molten all the metals and rocks, minerals are in the molten state. So that energy, we say that interior of the earth, that is also a source of energy. And one of the source of energy is tides, that is another source of energy. Now, definition. What is energy? So we can define energy as the capacity of doing work is known as energy. The amount of energy possessed by a body is equal to the amount of work done. Therefore, working body loses energy, and body on which work is done gains energy. Again, energy is a scalar quantity. Quantity. Unit of energy is The SI unit of energy is joule. Its bigger unit is kilojoule. That is kJ. Now, the relationship 1 kilojoule, that is kJ, is equal to 1000 joule. How can we define 1 joule? The energy required the energy required to do 1 joule of work is called 1 joule of energy. Now we'll study about forms of energy. Forms of energy. Main forms of energy are: first, kinetic energy; second, potential energy; third, heat energy; fourth, chemical energy; fifth, electrical energy; sixth, light energy; seventh, sound energy; Eighth, nuclear energy. So these are the different forms of energy. Sum of kinetic and potential energy of a body is called mechanical energy. This is a important concept. So mechanical energy is equal to is equal to potential energy plus kinetic energy. So it is mechanical energy is a sum of potential energy and kinetic energy. Now the definition of mechanical energy. What is the definition of mechanical energy? The energy possessed by a body the energy possessed by a body on account of its motion or position is called mechanical energy. Now, kinetic energy. What is kinetic energy? The energy of a body due to its motion is called kinetic energy. Example of kinetic energy can be a moving car, or a running car or a moving ball, rolling stone. This all can be the example of kinetic energy, flying aircraft, etc. Kinetic energy is directly proportional to the mass and the square of the velocity. Kinetic energy is directly proportional. This is a note you should remember. Note: kinetic energy is directly proportional to mass and the square of velocity. So we can write kinetic energy is directly proportional to mass and square of velocity. Now we'll derive a formula for kinetic energy. Formula for kinetic energy. If an object of mass m moving with a uniform velocity v uniform velocity u, it is displaced through displaced through a distance s constant force F acts on it in the direction of the displacement. Its velocity changes from u to v. Then acceleration is a. These are the condition. Again, let us check it. If an object of mass m moving with a uniform velocity u and it displaced through a distance s, constant force F acts on it in the direction of the displacement. Its velocity changes from u to v. Then the acceleration is s is a. In this case, so if we draw a diagram for this, so say this is the object, its initial velocity is u, its mass is m, and a force is acted here F, and due to this force this body moves from here to here, and this distance is this displacement due to force is s, and here the velocity is v. It changes from u to v, and the acceleration is as a. Rate of change of velocity is called acceleration, so the acceleration is a. These are the given conditions. Now from these conditions we will derive the formula for energy or work done. So we can write work done is equal to force into displacement. Instead of force, can we write ma and s? Here we know that force is equal to ma. So we know that this fact. Now according to the third equation of motion, motion relationship between relationship between u, v, s and a is as follows. B square minus u square is equal to 2as. Therefore, s is equal to v square minus u square upon 2a. So here we got, say, equation. We name this as equation 1. This one, this one is named as equation 2. And this one is named as equation 3. Now we'll we'll compare these equations. Then what we'll write? Put the value of f and s from equation 2 and 3 in equation 1. Now we can write w is equal to ma multiplied by b square minus u square upon 2a. So we can cancel out this a. So what is left? M by 2 into v square minus u square, which in turn can be written as half, or we can write m by 2 up bracket v square minus u square. If u is equal to 0, when body starts moving from rest, then we can write w is equal to half m v square, or kinetic energy is equal to half m v square. Let us do one problem related to the concepts. So problem is an object, and this is the end of today's topic. We'll start with this problem in the next session. Before we go, we will have a small request for you to subscribe, like, and share our channel among your friends and relatives. Please check all if please click on the subscribe button to support us and also click on the bell icon to get automatic notification. Thank you for your support.